Now, this said, I would like to hand over to my colleague Jan, and he will get a bit more into detail, and he will give you some concrete examples of our applications and the projects we are looking at.
Thank you very much, Anne, for the brief introduction of the technology as well as our company. If we may please go to the next slide. I will be talking about what we've done already, as well as what is in the pipeline and what might be interesting for you. So it goes without saying, the reason why we are all here is because we know that in Mediterranean it's becoming a little bit overwhelming. There has been some reports, or even a short report in TV, in the French TV, in particular for the port of Marseille, that people are suffocating, that the people living nearby the port actually cannot put their clothing outside because it becomes very quickly covered with soot, with the black particles. I guess that was the motivation for one of our first clients, which is the company La Meridionale, which operates a RoPax ferries. They are commuting between Marseille and Corsica. They wanted to implement something that hasn't been implemented yet, which is a system that can do a desox as well as removing the particles. As it was mentioned by my colleague, we do believe that particle removal regulation is just around the corner. It will make a logical sense because on land installations, they already do this. They already have this step integrated inside of it. So with La Meridionale, we started first trials already in 2019. In the meantime, 2022. That's okay, I can continue even without that, but in 2022, the system has been fully retrofitted. So it's now operational on La Meridionale. If any of you, as I heard, have been in the port, they even promote it heavily. The filter has a little description that they remove all the particles, I mean 99.9%. It's including the harmful particles that get stuck in the lungs. I mean, there the efficiency is slightly lower, is something like 96%. But still, that's pretty good result in comparison to no regulation virtually in any other ships that are sailing out there. I generally say it's a good anecdote. You know, I come from Germany and Port of Hamburg. I'm not allowed to drive with a car inside the city center because it's sort of ecological zone. So if the car is a little bit older, you cannot drive in. You have heavily regulated waste incinerators or power plants. And then you have 700 ships calling Port of Hamburg every single week. And they are not regulated from perspective of the particle removal. But anyway, that's just one thing that we already did. La Meridionale is sailing with the system, is doing currently desox and PM removal. And in the future, they will be also looking for possibilities on how to do a denox. I get to how exactly they do it a little bit later. There is another ship that this time is sailing in the Baltic SECA already. It's slightly less sustainable, I would say. We call it the basic dry system. In principle, you are injecting the sodium bicarbonate in. The sodium bicarbonate is neutralizing all the harmful emissions that are in the exhaust fumes and is being released through the funnel inside of the environment in form of a dust. As I said, a little less sustainable, but given there is no particular regulation just yet, this will allow the ship owner to capitalize on some savings with consideration to the gap that is currently out there. And they always have the option to put a filter on board of the vessel. So that's it for transition period, so to speak. If you go to the next slide, here is something that might be very much relevant to the port authorities, because there are two installations ultimately, or two options that the port authorities have as a service to provide to the ships that come inside of the port to be able to do what we implemented on the vessels, right? So the first option, believe it or not, already has been tested. And I did some research in 2014 in the port of Los Angeles and San Diego. There was a company that actually installed the dry system on the port, and they have been using a crate to put some sort of a cap, so to speak, on the funnel. Now, curiously, I haven't heard anything about that system since that time. I do believe this might be related to the fact that this particular dry system was based on lime. Now, lime, while it works, the reactivity and efficiency is not very good. And when we sort of heard one ship owner that was playing with the idea of putting this on the ship, he said, ultimately, I would need another ship to follow me in order to be able to treat my exhaust gases. So sodium bicarbonate, from that perspective, it's much more reactive, and as such, it's much more efficient to use in this installation. Simple principle, as it was already showed in the flow chart, the crane will put the cap on the ship exhaust gases. The treatment happens in a baghouse filter that is installed on the land. The residues are disposed of. It's non-hazardous residues. This hasn't been mentioned. They are disposed of in the matter that is available to us. We at Solvay are currently investigating different ways on how to make this into a circular economy, how to recycle these residues, to use them and reuse them again, to make this solution even more environmentally friendly and sustainable. The other option that is, I would say, the same ballpark, but gives maybe a little bit more flexibility, is to put the system on the barge or some sort of a ponton. This ponton can already be secured or put next to the ship already when they are maneuvering. And then it's fundamentally doing the same thing. It comes with the ship to the port, it's treating its exhaust gases, and then when the ship is finally leaving, the ponton will be connected and can do it for some other ship as well. So these two options, we already had some investigation that we ran internally. For the baghouse filter, we have been previously working with the company Andritz that also participated on the La Meridionale project. But of course, the baghouse filter manufacturers, we can be selective and we can work with whoever manufactures these baghouse filters. That's not a problem whatsoever. Moving forward, what else is in the pipeline? So what else in theory should be possible? If we go to the next slide, please. So we spoke briefly about the, let's say, the open loop or basic dry system that is emitting the residues, that is releasing them back to the environment. While this is not regulated, we would like to see some sort of filtration, some sort of dedusting. And we are right now, together with the company Sodaflex, which is a UK-based, looking at the different ways on how to do it, because baghouse filter is relatively bulky. It's small, it's big, it's heavy. So for that reason, we are looking at the different solutions, for instance, the use of cyclones. Now, cyclones will never have such a removal efficiency as a baghouse filter does, but at the same time, maybe for the transition period, from perspective of space, weight, and capex, it might be a viable solution. Furthermore, we are looking at a combination with catalytic Danox system. So if we come back to the baghouse filter, it has certain filter sleeves that are put inside the baghouse, right? They are fabric-based sleeves. What we can do is we can put a catalytic sort of sleeves on top of these, and then at the same time, we can actually do DSOX, DNOX, and PM removal. So ultimately, you have one machinery, one equipment to do all three of these things, which is by far the most sustainable solution. We will be testing that in real marine environment on RoPax Piana shortly. Finally, we are running an investigation on combination with CO2 removal. CO2 removal and carbon capture, it's a very big topic right now. It's not as easy to do because before you do the carbon capture, the exhaust gases must be completely cleaned. However, there might be some options that we are currently investigating, and hopefully we are pretty close to be able to pull it off as well. So that is the ultimate vision, to have 4-in-1 solution: DSOX, DNOX, PM removal, and carbon capture at the same time. Once we are able to establish that, we are hoping that this is something that really gets picked up, and that also the ship owners or the port authorities will recognize the importance that this plays in order to protect the people living nearby the coast, as well as, of course, the fauna and flora inside the seas. That is all from my side. Thank you very much.